Some people look at the stars and see points of light, others see burning balls of gas trillions of miles away. But Sir Roger Penrose sees a story, one that stretches before and beyond our universe. Penrose is a mathematical physicist, Nobel laureate, and a challenger of consensus. He's not afraid to ask, what if we've got it all wrong? Imagine the universe as a grand puzzle. Most physicists have built a beautiful picture, but Penrose points to pieces that don't quite fit. He suggests we might need to rethink the very shape of the box. This isn't arrogance, it's relentless curiosity. Penrose's journey is a testament to independent thought in a world that often rewards consensus. His work on black holes helped solidify Einstein's theory of general relativity, yet he now questions cosmology's most accepted ideas. He reminds us, even our most cherished theories are just maps, and every map has edges waiting to be explored. This is the story of a knight's quest, not with a sword, but with the formidable power of the mind. We'll travel to the supposed beginning of time, and peer into the unseen future. We'll question the very substance of the universe. With Penrose as our guide, we'll dare to ask, are we living in the first universe or just the latest in an infinite series? Is the cosmos filled with mysterious, invisible matter, or is there a grander, simpler explanation? Let's begin the journey. To understand a rebellion, you first need to understand the empire. In cosmology, the empire is the lambda CDM model, the standard model of the universe. This story begins with the Big Bang. About 13.8 billion years ago, everything erupted from a singularity. The universe expanded, cooled, and has been growing ever since. As it cooled, the fundamental forces separated, atoms formed, and the universe became transparent, releasing the cosmic microwave background, the universe's baby picture. But the standard model says what we see, stars, planets, galaxies, is just 5% of what's out there. About 27% is dark matter, invisible, undetectable, except by its gravity. The remaining 68% is dark energy, a mysterious force pushing the universe apart. So, our universe is mostly made of things we can't see or explain. The lambda CDM model is supported by mountains of evidence, redshift, the CMB and more. It works. But does it tell the whole story? Why is so much of the universe invisible to us? Why did it begin in such a special state? These are the cracks Penrose wants us to notice. The standard model is powerful, but it leaves us with profound mysteries. Is it the final word or just the best story we have so far? Penrose thinks we need to look deeper. Let's zoom in on one of the biggest mysteries: dark matter. In the 1930s, Fritz Zwicky noticed galaxies spinning too fast for their visible mass. Vera Rubin confirmed it decades later. The outer stars and galaxies move as fast as the inner ones, defying gravity as we know it. The only explanation, a vast halo of unseen mass, dark matter holding galaxies together. We see its effects in gravitational lensing and the cosmic microwave background. The standard model relies on dark matter to explain how the universe evolved from a hot soup to the structured cosmos we see today. But after decades of searching, we haven't detected a single dark matter particle. Physicists have built sensitive detectors deep underground hoping to catch a WIMP, a leading candidate for dark matter. So far, nothing. The ghost remains a ghost. This is where Penrose steps in. When a search this long turns up empty, maybe you're not just looking in the wrong place. Maybe you're looking for something that isn't there at all. What if the universe doesn't need dark matter? The Big Bang is the ultimate origin story. But what if it wasn't a beginning at all? The standard theory presents a singularity, a point of infinite density where physics breaks down. For Penrose, this isn't an answer, it's a crisis. The second law of thermodynamics says entropy always increases. Things go from order to disorder. But the Big Bang requires the universe to start in a state of incredibly low entropy, an absurdly special, ordered state. Why? The standard model just says, that's the way it was. Penrose finds this unsatisfying. A complete theory shouldn't require such fine-tuned initial conditions. He looks at the two pillars of physics, general relativity and quantum mechanics. They don't play well together, especially at the Big Bang. The singularity is where these realms collide. Penrose believes we need a unified theory, a quantum theory of gravity, to truly understand the beginning. He suspects a better theory would eliminate the singularity, replacing it with something else. Maybe the Big Bang wasn't the beginning, but a transition. What came before? Penrose dares to ask. The answer could change everything we think we know about the cosmos, and that's where his boldest idea begins. If not the Big Bang, then what? Penrose proposes conformal cyclic cosmology, CCC. In CCC, our Big Bang wasn't the beginning but the end of a previous cosmic era, an eon. The universe cycles through infinite births, expansions, and rebirths, a cosmic phoenix. Here's how it works. Our universe expands, stars burn out, black holes evaporate, and all that remains is a cold, empty universe filled with massless particles. In this distant future, time and distance lose meaning. A vast, empty universe looks mathematically identical to a tiny, hot one. Penrose uses a conformal transformation, a mathematical rescaling to show that the end of one universe becomes the Big Bang of the next. The end of one eon is the beginning of another. What's exciting is that CCC might be testable. Penrose suggests that colossal black hole collisions in the previous eon could leave faint circular patterns, Hawking points, in our cosmic microwave background. He and his collaborators claim to have found these patterns, though the evidence is hotly debated. If true, it would be the first glimpse of a universe before our own. CCC offers a vision of endless cosmic renewal. It's a radical idea, but it could explain the mysteries the Standard Model leaves unsolved. Is our universe just one chapter in an infinite story? Penrose invites us to imagine it. Entropy is the arrow of time, the reason we remember the past, not the future. The universe always moves from order to disorder. The Big Bang's low entropy is a statistical miracle, like a trillion puzzle pieces falling perfectly into place. The Standard Model just accepts this as a brute fact. Penrose finds this unacceptable. His CCC model solves the problem. The low entropy of our Big Bang is a natural consequence of the end of the previous eon. At the end of an eon, the universe is in maximum disorder. But when you rescale it, the gravitational degrees of freedom where most entropy hides are squashed out. The high entropy end becomes the low entropy beginning. The universe gets a clean slate. The arrow of time is relaunched with each new eon. No special pleading, no fine-tuning, just a natural cycle. It's a profound idea about the nature of time itself. Proposing CCC, Penrose doesn't expect applause. The scientific community is conservative for good reason. The Standard Model works. Most cosmologists see Penrose's ideas as fascinating but speculative. The main objection: lack of definitive evidence. Penrose's Hawking points in the CMB are debated. Many analyses find only statistical noise. Science demands overwhelming proof for extraordinary claims. CCC also relies on speculative physics, like proton decay and a future theory of quantum gravity. Critics say Penrose is building on unproven assumptions. Still, Penrose persists, publishing, refining, and challenging his peers. As a Nobel laureate, his ideas can't be dismissed. Even if CCC is wrong, it forces us to confront deep questions about the universe. Why does this debate matter? Because it's the pinnacle of human curiosity. Penrose's work reminds us the quest to understand our place in the cosmos is far from over. The Standard Model gives us a universe with a definite beginning and a lonely end. Penrose's CCC offers an epic, endless drama, death and rebirth on a cosmic scale. It connects us to a past and future stretching through countless eons. By questioning dark matter, Penrose forces us to think critically. Maybe it's a patch, not a solution. His challenge keeps science healthy, preventing dogma. The value of Penrose's work isn't just in being right or wrong, it's in the act of questioning. He embodies the spirit of scientific revolution. Copernicus, Einstein, Penrose each dared to question the foundations. These leaps of imagination drive progress. They remind us the universe is likely far stranger than we imagine. And that's the true beauty of science. We stand at a fascinating moment in science. Our Standard Model is powerful but incomplete. 95% of reality is invisible and unexplained. Into this landscape, Penrose casts his challenging ideas. He invites us to imagine a grander, eternal story. Science isn't just about answers, it's about better questions. Every beautiful theory is destined to be replaced or absorbed into something deeper. Penrose's work may be a footnote or a new beginning. Either way, he keeps the conversation alive. Next time you look at the night sky, see the questions. Are we living in the first universe or just the latest in an infinite series? These questions belong to all of us, the birthright of every curious mind. The cosmos is the ultimate mystery, and we are its consciousness. The invitation to wonder is always open. All you have to do is look up.